So again, bumper carts, your date here, 150 kilogram with the cart going 2 meters per second. You and your cart, 200 kilogram going 5 meters per second. You bump into them. We're not sure what's going to happen. We're making the assumption both carts going to go forward with velocity v1 and v2. Now, if I do the math and it comes out velocity v2 is 0, that tells me, bless you, that tells me what? That this cart stopped and this one went bouncing forward. If I get v2 being negative, that tells me, guess what? This one went backward and that one went forward. So the math will tell us what's going on. When you have elastic collision, there's two things actually. In elastic, we have conservation of linear momentum. Elastic collision, when you have elastic, again, elastic means they don't stick together, they bounce off each other. We have two conditions: conservation of linear momentum and the second condition, conservation of kinetic energy. With inelastic collision, we do not have conservation of kinetic energy, only conservation of linear momentum. So let's see. Let's look at conservation of linear momentum. The initial linear momentum is equal to the final linear momentum. What's the initial linear momentum? This is the initial. It's the mass of the first one, which is 150, times the velocity of the first one, which is 2, I'm using to the right as positive, plus the mass of the second bumper cart, which is 200, times its velocity, which is 5, equals. Now they don't stick together, so I can't add the masses. The mass of the first one, which is 150, times the velocity, which is v1, plus the mass of the second one, which is 200, times the velocity, which is v2. $300 plus 1,000 equals 150 v1 plus 200 v2. $1,300 equals 150 v1 plus 200 v2. If you want to make the math a little bit easier, you can drop a 0 out of each one, just mathematically, just to make the number a little bit smaller, the numbers. You can even divide by 50. You know what? Maybe I'll do that. I'll divide each one by 50. I can divide by 150 probably. Can I, what's 200 divided by 150? Oh, that's a decimal value. Let's divide by 50, each one by 50, just to make the number smaller. So that will give me what? 1,300 divided by 50, 26. So this is just algebra to make the numbers a little bit smaller. 3v1 plus 4v2 instead of dealing with big numbers. That's equation number 1. So I'm going to write here, because people say, why did you divide by 50? Divide by 50 to simplify. Not to do with physics. Has nothing to do with physics. we divide each one by 50 so we can make the numbers a little bit smaller. So I did use conservation of linear momentum. Now I got to use conservation of kinetic energy. Kinetic energy, which is what? The kinetic energy before should equal the kinetic energy after. Let's look at the kinetic energy now. That 1/2 mv squared. 1/2 the mass, which is 150, times what? 2 squared, plus 1/2 times the 200 times what? 5 squared, equals the after 1/2 times 150 times v1 squared plus 1/2 times 200 times v2 squared. $300 $2,500 75 v1 squared 100 v2 squared. Okay, 2,500 and 300 is what? 2,800. $75 v1 squared plus 100 v2 squared. Is that what we got? I could probably divide by what? 25 to make the math smaller. Again, divide by 25 to simplify. So what's 2,800 divided by 25? 112 equals 3 v1 squared plus 4 v2 squared. And now we have two equations by two unknowns. Physics is done for now. How do we solve these two equations? So I'm going to put them on the next page and go through the math and solve them. So here's my two equations. And this is where the math becomes fun. 26 equals 3v1 plus 4v2. 112 equals 3v1 squared plus 4v2 squared. How would you solve this? How would you solve these two equations?
Can you combine them? Or no?
You mean, what do you mean by, Alyssa? Combine them? Add them?
Yeah.
Can't, because this is v squared and that's v.
Oh.
See, this is squared, that's not. But I can use substitution, right? I can solve for one of them. Like if I solve for v1 or v2 in one of them, I will say 3v1 equals what? 26 minus what? 4v2? Which means what? v1 equals 26 minus 4v2 divided by what? By 3? Now let's take this one and plug it in. 3 times. In place of v1, let me write what v1 is. v1 is 26 minus 4v2 divided by 3, and you're going to square it now. Plus 4 times v2 squared. Now you can see there's only one unknown. If I can simplify the math, I'll be in good shape. I got to square this, which means multiply it by itself. Multiply it by itself. And the 3's will cancel each other out. These two 3's. I still have a 3 in the bottom. 112 equals 26 minus 4v2 times 26 minus 4v2 divided by 3 plus 4v2 squared. To get rid of the 3 in the bottom, you multiply every one of them by 3. This 3 cancels that. Now there's no more fractions. 3 times 112 is what? 3, 3, 6 equals 26 minus 4v2 times 26 minus 4v2 plus 12v2 squared. And I got to use the FOIL method here. What's 26 times 26? There's my calculator. 676. (26) times a negative 4. And there's 2 sets of them. Negative 208 V2. There's 2 sets because there's the second set right here. And the last one, what's negative 4 times a negative 4? Plus 16. If we combine like terms, move everything to one side, this is what we're going to have. What's 12 and 16? 28 V2 squared minus 208 V2. Bring this one to this side, becomes a minus 676 minus 336, 340. I think I can divide each number by 4 to shrink it. So divide by 4 to simplify. I want my numbers small. I don't want to use big numbers. 0 divided by 4 is 0. 28 divided by 4 is what? 7. 208 divided by 4. Is that 52?
Yeah.
340 divided by 4. Is that 85? And now we need to solve that quadratic equation. To solve it, you can try factoring. Good luck. It might be actually. I just don't want to think about it. Or I can use quadratic formula. I can use that. B is negative 52. So minus a minus, that's plus. Four times A is 7. C is what? 85. Divided by 2A. 2 times 7. $52 plus or minus the square root of 52 square, 2704, minus 4 times 7 times 85, 2380, divided by what? 14. Let's subtract them and take the square root in one shot. 2704 minus 2380, 324. Take the square root of that number. Happens to be 18. Interesting. Exactly 18. I made that up without thinking about it, and I got a whole number. So one solution for V2 is going to be 52 plus the 18 over 14, which is 5. And the other solution is what? 52 minus the 18 over 14. Which is 2.43. We need to find what V1 for each one. Again, we have two answers for V2. We have V2 equals 5, and the other answer, V2 equals 2.43. Well, let's find V1 and see if it makes any sense. This is what V1 is equal to. We did that early. We have that equation. So when V2 equals 5, what is V1? Plug it in here. 26 minus 4 times V2. V2 is 5. 4 times 5. And you divide it by 3, and that's a 2. And right here, when V2 equals 2.43, let's see, 26 minus 4 times 2.43, divide that by 3, 5.43. These are my two sets of answers. Now, physically, one of them is not going to make any sense. Let's go back to the picture. You are in your go-kart. You're number 2 here. You're going 5 meters per second. This one's going 2 meters per second. You hit each other, and based on this answer, the one in the bottom here, you continue to go on the same speed. That means this one continued to move at 5 and this one continued to move at 2. How is that possible? The only way that could happen if there's a hole inside this and you just slide through it. You never even hit them. There's no way this one will continue to go 5 and this one going slower. You'll drive over them. So that doesn't make any sense. So this solution is out. The second one says, you know what? V2 here is positive, which means continue to go forward, but slow it down. It went from 5 to what? 2.43. And what happens to V1? It picked up some speed. It was going 2, now it's going 5.43. So when you hit them, they go flying forward, and you slow down a little bit there. And that's possible. That's absolutely possible. What you actually find out, we'll go through that, if they are the same mass. If they are the same mass, their velocity will flip. Whatever this one has, this will, whatever this one has, this will have, whatever this one has, this will have. So if the mass were the same, this one will go forward with 5, this will go forward with 2. If the smaller one hits the bigger one, if a smaller object hits a bigger one, what you notice is the smaller one goes backward and the bigger one goes forward. If you watch this, you take your calculator and you hit a pen, or a pen hits the calculator. Here's a pen. Watch, the calculator is going to hit the pen. They're both going to go forward, but the pen will go forward much faster. If you do the reverse, because this is smaller, if a pen hits the calculator, the pen is going to go backward. This will move forward slowly. See how it goes backward? If they are the same size, like in pool, when you hit a pool dead on, what happens? This one comes in, stops, and this one goes forward. But again, all these, if one is not moving, if you hit them hard, and they're the same mass, this will stop and this will go forward if they're not moving. As I said earlier, the math gets a little bit hectic with these problems. And it could get worse than that, especially when you have 2 dimension. You're dealing with 4 equations by 4 unknowns. Our book came up with an equation that seems to work to avoid the math. This is the picture they have here. We'll see if their equations tend to work or not. They label them as mass 1, this is this one, and this is mass 2. So the one that's moving, this is not moving, by the way. These equations that you see right here, if this is not moving, in the example we did, we can't use them because that was moving. So this, actually, somebody did the math for us and go, you don't have to use substitution solver, just use that one. But again, this one, if this is not moving, only M1 is moving. What will happen to M1, the velocity of this one, the found velocity for it, will equal mass 1 minus mass 2 over mass 1 plus mass 2 times the initial velocity. The little one who was stationary before, their velocity will be 2 times m1 divided by m1 plus m2 times v0, the velocity of this one. So somebody, instead of going through the physics to do conservation of linear momentum, conservation of kinetic energy, they did all the math like this. They went through it, cleaned it, and came up with that one. Again, you can only use these if the second one is not moving, to avoid the math, to avoid the quadratic formula there. If the second one is moving, these equations are useless. Can't use them. Now, I'll do them with when one is not moving, and I'll show you the math for them is not really that bad when one is not moving. I mean, it's still going to be work there. Still way more work than this, but we'll plug these numbers to see if they do work out or not. Then we'll deal with two-dimension. So I have bowling. The ball comes down. Let me draw a picture of a ball here. Bowling. Again, we're going to hit them straight ahead. Dead on. So it's going to go forward. What's the mass of the bowling ball? Anyone? The big bowling balls. Any idea?
Like 2 kg.
Okay, 2 kilogram. 5 pounds, probably more, but we'll use 2 kilogram. It comes and hits the pen. There we go. The pen is not moving. Let's say this is 1 kilogram. This is moving forward with a good speed, 5 meters per second. So the velocity of this is 0. They collide again, they hit. This is the 2 kilogram. It's going to move forward, and this is the pen is going to go flying. V1, V2. What are the final velocity after they collide? After this one hits this, right smack in the center. If you ever watched the game on TV or played that game, you know they don't stick together. So we have conservation of linear momentum and conservation of kinetic energy. We'll begin with linear momentum before equals the linear momentum after. The before is the 2 kilogram times the velocity, which is 5, plus the 1 kilogram times the velocity, which is 0. The after, it's the 2 kilogram times the velocity, which is V2, plus the 1 kilogram times the velocity, which is V1. And that's my first equation. I can solve for V1 and use substitution again. Notice V1 will be 10 minus 2V2. It won't be bad here. No fractions. The kinetic energy before equals the kinetic energy final. 1/2 the mass, which is 2, times 5 squared, one half times 2 times V2 squared plus 1/2 times 1 times V1 squared. 25 equals V2 squared plus 1/2 V1 squared. So this is really not bad if you want to do it with math, because you can look at this, that's your second equation. You can look at the first equation and go, I know what V1. V1 is what? 10 minus 2 times V2. And plug it in here. So if you plug it in, that's why I don't like the equations, because now you're memorizing things. You come back to this, and when one is not moving, as I said, the math is not bad. 25 equals V2 squared plus 1/2 times V1, which is what? 10 minus 2 V2, and you got to square that one. Let's FOIL this, multiply it by itself. That's 100 minus 40 V2, 40, plus 4 V2 squared. Plus 50 minus what? 20, 2 V2 squared. Collect like terms, move everything to one side. And you go to the quadratic formula. If you don't want to do all this math, so I'll just go simplify. Or solve instead of simplify. I'm not going to solve it, because I'm going to use their equation, similar to what we did before. Now you've seen the quadratic formula, so you know you can solve it. If you want to use their formula, the one they give us in the book, for an example like this, where the second one is not moving, you can. They labeled this one, the moving one, as V1. This is your V1, equals 5. This is mass 1, that's not moving, that's 2 kilogram. The one that's not moving has a mass 2, which is 1, the velocity is 0. That's the initial velocity, VO, initial velocity. You can figure V2 and V1, except they label them backward because they call this one 1, they call that one 2. So if you decide to go in that direction, they call this one V1 in our book, the one that's moving, and they call this V2. And on that page, I forgot what page number, it says if you want to find the V1, it's mass 1 minus mass 2 over mass 1 plus mass 2 times the V initial. And if you want to find V2, it's going to be twice mass 1 divided by mass 1 plus mass 2 times V initial. What I don't like about this is you never really have to do any of these. You just look at that picture, identify the pieces, and there's your answer. That defeats the whole purpose of physics. You don't even have to apply these. So you know on the test, I'm not going to give you a 0 not moving there. I'm going to have you go through that. But for those people who want to use that to see how it works, you plug them in. Mass 1 is 2, mass 2 is 1. 2 minus 1 over 2 plus 1 times the 5. That's 1/3 times 5, which is 5 over 3. 2 times 2 over 2 plus 1 times 5. 4 over 3 times 5. 20 over 3 meters per second. No need to use conservation of linear momentum or conservation, because they did the work for you. These are the result of using these two. I don't like them. And I know if I gave you one where the initial velocity was 0 for this, I know you're going to use that, so I got to make sure you don't see any of them on the test. You might see one on the homework, but you won't see it on the test. You have to do conservation of linear momentum. Show me you can do that. Show me conservation of kinetic energy, and go through the math and solve them. Now, the last example I'm going to do before we head to the lab, and that is two-dimension. Curling is the stupidest game there is, but I see that on TV and I'm glued to it. I don't know the rules, but I see them trying to get that stone in the center of the circle, and they're hitting all the stones and everything. And what happens when two dimensions, sometimes the stone will comes in, and all the stones have the same mass, and you'll try to hit this one on an angle, like hit it right there, if this is 1 and this is 2. If you hit it right there, what's going to happen, number 2 probably going to go in that direction, and number 1 probably is going to go in that direction, I mean. Not dimension, direction. So we have movement in 2 dimension here. And if we don't give you anything, you're going to have 4 equations by 4 unknowns, and nobody wants to solve that. So let's assume all these stones are the same mass, just like when you're playing pool. The 2 balls are the same mass. This one has initial velocity of 1.5 meters per second. It hits this one, which has initial velocity of 0. And what we notice that number 1 went in this direction. We have no idea what the velocity of that in this direction. We'll call it V2 or V1. That's number 1. So to make sure I don't solve 4 equations by 4 unknowns, I'm going to give you some information. This angle theta. I'm going to say I wasn't paying attention to this, but I noticed this one moved in that direction at a speed of 0.61 meters per second. 0.61. And somehow I measured that angle, and I found that angle to be 66 degrees. I'm giving you these two so you don't have to have 4 equations by 4 unknowns. You're only going to have 2 equations by 2 unknowns now. And that's more doable. Otherwise, you have an unknown, 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 4 of them. And you got to find all 4 of them, 4 equations by 4 unknowns. Good luck. There goes your weekend. You know? So now we have to look at the x direction and the y direction. Just like we did before. Conservation of linear momentum and conservation of kinetic energy in both dimensions. So x direction let's do first conservation of linear momentum. In the x direction, this was moving 1.5, the mass of it m, I didn't give you the mass because they're the same mass, 1.5 meters per second. Second one has a mass m, velocity in the x direction was 0. Now, this one in the x direction is going to be mass times the velocity, which is what? v1 cosine theta. The component of that velocity in that direction. And the other one is going to be what? The mass m times the velocity in the x direction, which is 0.61 cosine 66. That's in the x direction. The good news, every term has m in it, so I can take my red pen, divide each one by m. I have 1.5 equals v1 cosine theta plus, what is 0.61 times cosine 66? Oh, my calculator in radian mode from last night, because I got a negative value. I know that's not correct. Let's get out of this. 0.61 times cosine 66. 0.248. 0.25 is good. Clean that, bring the 0.25 to this side. 1.25 equals what? v1 cosine theta. Now, let's try in the y direction. In the y direction, the mass of this is m. What's the velocity in the y direction? 0. The mass of this, which is what? M times the velocity in the y direction, which is 0. Equals the mass of this times the velocity, which is v1 sine theta. Notice I put theta in that direction. I don't want to say negative theta or negative value because I don't know if it's going to be down. If theta comes out negative, the math will tell me, then my picture is correct. Plus the mass times what? 0.61 sine 66. So what do we have? I might have given you too much stuff, so you don't have to do 4 equations by 4 unknowns. We have what? 0, because you can cancel the m's. Equals v1 sine theta plus 0.61 times the sine of 66. -0.56. Clean this one. Actually, I lucked out with the information I gave you. I didn't even have to use conservation of kinetic energy. Right there. How many equations by how many unknowns you see there? 2. I don't even have to use conservation of kinetic energy. 1/2 mv squared plus 1/2 mv squared equals 1/2 mv squared plus 1/2 mv squared. I didn't need it here because I gave you this, this, and that. I took the problem from the book, so they're giving us too much stuff. So now you get 2 equations by 2 unknowns. Here's the first one. I always write sine on the top, cosine on the bottom, because I like to divide them. One of the easiest way of solving them for me is divide them. So if you divide them now, the v1s will cancel each other out. Sine over cosine, which is what? Tangent theta. Negative 0.448. What is theta? The inverse tangent of negative 0.448, and if it's negative number, my picture was correct because I drew it below, but I don't want to go positive, negative. I said, let the math tell me that. And it says theta will have to be negative 24 degrees. So notice by not saying, well, this is coming down, I should make that negative. I said, let the math tell me that. I don't want to do it. Let them tell me that. And once you know that, can you find V1? Doesn't matter which equation we use. Can I get V1? Negative 0.56 divided by the sine of negative 24. V1 is 1.38 meters per second. Usually we don't give you that many things. Again, I took this example from the book, which they've given us both of these, so I made the math a little bit easier. I don't have to use even conservation of kinetic energy. It's only 2 equations by 2 unknowns. If I had 3 of them, then I have to go conservation of kinetic energy. We'll see on the homework if I give you something with that. But it's time for us to get to the lab now.